in this force, sorry, in this charges, this is q1, q2, this is q3, and q1 is 4 microcoulomb, q2 is minus 5 microcoulomb, and q3 is 6 microcoulomb. Distance between them, between q1 and q2 is 200 centimeter, and the distance between q2 and q3 is 400 centimeter. So as we can see, first of all, we should decide that we are going to find the resultant force on q2. Let's suppose, okay. So resultant force on q2, if we can see here, uh, that the on q2 the force from q1 is an attractive force, and from q3 also it's an attractive force. So if I will draw it here, so it will be, you can say that the resultant, because q2 will be attracted towards q3, and q2 also attracted towards q1, so they both have attractive forces. q1 and q2 have attractive, and q3 and q2 have attractive forces. So when q3 and q1 will apply a force on q2, so if I will draw it here, let's suppose there is some force on this side and there is some force on this side, okay. So as a result, what we will do now, strategy is separately we will apply the Coulomb's law in these two charges. We will get a force, and then we will apply Coulomb's law in these two charges, and we will get a force. And if you people remember, we used to study from smaller grades, like if I have 5 Newton force here, and then we have 10 Newton force here, okay. So the resultant force will be 5 Newton on this side. This is our resultant force. So we will do the same method, that we will calculate the forces between them, and then simply we will check that which force is the dominating force, so we can say that what is the relevant force related to that. So let's start with by the help of this calculation, okay. And we have here 6 microcoulomb, okay. So if I will apply the force on these two, let's suppose I give a name on these two, F12 force, and it will be equals to K Q1 Q2 divided by R square, yani R is the distance between them. So if I will apply a formula, K value we know, we studied already, it's 9 cross 10 power 9 multiply by Q1. Q1 is 4 and it's 4 microcoulomb, so I will convert it into coulomb. 4 cross 10 power minus 6, okay. And similarly, if it's Q2 is 5 cross 10 power minus 6, and it's 5 multiplied by 10 power minus 6. So this is and then I can simply divide them with R square, the distance between them. So I'm repeating again, this is K, 9 into 10 to the power 9, the constant between them. Q1, this is the formula of Coulomb's law, we already studied. F is equals to K Q1 Q2 over R square. So Q1 is 4 into 10 to the power minus 6, and Q2 is 5 into 10 to the power minus 6. I'm going to ignore this negative, because I am just going to find the magnitude between them. It's a simple way. So R, because it's 200 centimeter, so I must convert it into meter. 200 divided by 100, so it will be 2 square. So R between them is 2 square, 2 power 2. Okay, so if I will calculate the answer by using calculator here, so 9 into 10 raised to power 9 multiplied by 4 into 10 raised to power minus 6 and 5 multiplied by 5 into 10 raised to power minus 6 divided by 2 square. So answer will be 0.05 0.045 Newton. Similarly, now I will calculate the force, which is force between Q2 and Q3. So I'm going to calculate F23, which is equals to, again, the same formula applicable, 9 cross 10 power 9 multiply by, now Q2 is 5 cross 10 power minus 6, 10 power minus 6, and multiply by Q3 is 6 cross 10 power minus 6, also to convert it into microcoulomb into coulomb here. And then the distance between them is, it was written, sorry, it was 400 here, it was 400 centimeter, then it was raised a little. So the distance between them is 400 centimeter. So that 400 centimeter will be converted into meter, that will be 4, and then due to r square it will be square. Okay, so the F23, the force between Q2 and Q3 is 9 into 10 is to power 9. Again, I am going to take the magnitude, not taking the negative here. It is easy. Then later by using the simple calculation, we can tell them the resultant force. 6 into 10 is to power minus 6. And then if I will calculate the answer here, it is 9 cross 10 power 9 into 5 into 10 is to power minus 6 multiplied by 6 into 10 is to power minus 6 divided by 4 square. So the answer is 0.0168, which I can write at 0.017 Newton. And now I can see here easily that F23 is 0.017 and F12 is 0.045 Newton. Yani the force between F12 is bigger than the force on F23. Yani between these two. So the force on Q1 and force here, which is this side, yani on the left side, is greater than the force on the right side. Why? Because here the distance is smaller, and we know if the distance is smaller, according to Coulomb's law, Coulomb's law, and that is, we already studied that the force between two charges is equals to K Q1 Q2 over R square. Okay, so that if we can just see the relationship here, then the relationship of R is inverse, in fact double inverse relationship you can say, because better we will write here R square simply. So if R will increase 2 times, the force will reduce uh, 4 times, and if R will be decrease 4 times, the force will be increase, R will decrease double, the force will increase 4 times. So here R is less, that's why the force on this side is more as compared to the force here, and that is the reason that the force in this side, left side, is more than the force, because the distance between Q2 and Q3 is more. So now I will find the resultant force. Resultant resultant force on Q2 is equals to 0. We can write here F 12 minus F23. It will be equal to 0.045 Newton minus 0.017 Newton, and the answer is 0.028. And with this I must write the direction also, and this direction, because as we already discussed that the resultant force is dominating on the left side force is greater, so we can write here that 0.028 to left, yani with also we will define the direction here. Direction is very important, that's why I make it easy that ignore the negative sign in the start, just decide the forces in the start, that on Q2 what two forces are there, and then simply calculate the forces, okay, and then you can find the direction easily with magnitude also. Now let's suppose I can draw another phase here, simply that I have positive here, okay, and then I have, you can say, better I could suggest that I have positive here also, and then I have positive here also. So these three charges are positive charges here, and they are like charges, and we know that the like charges will repel each other. So let's suppose in this case, if I have to find the resultant force on this, now this is the Q2, let's suppose this is Q2, and I have Q3 here, this is Q3, and this is Q1, then in this case Q3, so in this case this Q3 will repel, so there will be a repulsion force here, okay, and this should be Q1, okay, and Q3 will also repel Q2. So again this time there is a repulsive force, and we will again take the same thing, that we will calculate the force between here, and we will calculate the force between here, and then we will find that which force will be the dominating one. So if this force, the force from this side will be greater, Q2 will move there, and if the force from this side will be greater, Q2 will move on the opposite side, so that force will decide. And again we have to minus them to get the resultant force. It's similar that between Q1 and Q2, and Q2 and Q3 is a repulsive force, so we will get by minusing them. So in the start we must find the forces, that what type of the forces are there, and then on the behalf of this I can draw another scenario. Let's suppose negative is here, and we have positive here, and we have another positive here, and now I want that, let's suppose the force on this Q1, let's suppose this is my Q1, this is my Q2, and the last is my Q3. And if I have to find the resultant force on Q1 from Q2 and Q3, so obviously from Q2 it's also an attractive force, and from Q3 also an attractive force. So these two forces are going to attract, you can say, these two forces are going to attract it on the right side, okay. So from Q2 also we will calculate the force, and from Q3 also we will calculate the force, and then because both these forces are attracting Q1 towards the right side, okay, so here in this case the resultant force will be on Q1 will be on the right side also. So in the start, the most important thing which you should see in this type of questions, that they are asking the force on which charge, okay, and this charge is placed where. So according to this you can decide the resultant force, and then you can apply Coulomb's law and then find the resultant force on them. Okay, so that's the case here. uh, in this case we can see about the force on different charges here.